Hello, everybody. Hi. Welcome to this session. Thanks, everybody, for coming. So, let's see where we are and what we have to present to you today. So, my name is Giorgos Andrianakis. I am a principal software engineer at Red Hat. I work on the project that I'm going to present here today. The project is called Quarkus, and the the name of the presentation today is Quarkus, a best-in-class Java framework for developing cloud-native applications. So the title is sort of a mouthful, so let's try and break it down. Um, uh, uh, Word by word. Okay, so what we're talking about here, like the general idea is that we're going to be talking about a Java framework, right? So for folks who have intimate knowledge of the Java space, that you'll think of things like frameworks like Spring Boot, which is the probably the most well-known framework in this space. For folks who have not been participating in the Java space for a while, think of like frameworks like in other stacks like Node.js or Ruby on Rails, things like that. So what we're trying to do here is to present this Java framework. We're going to show why it's important in the Java space, what problems it's tailored towards, and we're going to show some code like that will just demonstrate, hopefully in a good way, what this framework can achieve. So as I think I messed up here. I think I have not shared my screen, right? Yes, sorry about that. So hopefully now I'm sharing my screen and the presentation is being displayed here. So like I said, Quarkus, best-in-class Java framework for developing cloud-native applications. So let's get this started. I'm assuming everybody can see my screen. My Zoom says that I'm sharing, so everything should be fine. Okay, let's get the basics out of the way. What is Quarkus? Quarkus is a stack, so a framework, let's say, that allows you to write Java applications that target basically new style deployments. So you're writing cloud native applications, or you're writing microservices, or even serverless applications, right? So Quarkus allows you to write any sort of application, but the problems we try to solve and the use cases that it's best tailored for are cloud native applications, microservices, and even serverless applications. That's not to say that you can't write a monolith for Quarkus. So you definitely can, and you'll have a lot of benefits. But the most benefit you'll get is from writing applications that target these environments. So let's see. Well, Quarkus at a glance. So basically, Quarkus was released in 2019. The development was started in 2018. The first version was released in 2019. So we've since then, Quarkus has grown to be what we see now, based on the data, is the second most popular framework in the Java ecosystem behind Spring Boot. Let's say for some indicative numbers, let's give these facts. So we have like 11,000 GitHub stars, about more than 720 contributors. We have hundreds of extensions. Extension is basically like a way for you to for users or library authors to integrate their library into Quarkus. So we have more than 500 of those. We do releases almost every month. So we've, since 2019, when we first released, we have had like over 75 releases. The latest version is 2.14, but sometime next year, we're going to pivot to version 3. And I can answer more questions about why we're doing that later on if let's get down to like why Quarkus exists, right? What is the reason that we came up with Quarkus? What problems are we trying to solve? So what is the best way to write cloud native application in Java, right? So anybody who has not been working in very legacy systems for the past few years knows that in today's environment where we're trying to deliver business functionality as fast as possible, trying to create create a good experience for users, that often enough means that we need to break up our big old monolithic application into smaller applications that can be deployed independently. And so this is usually called a microservices, or if you take it to the extreme where you're very much limiting the size of each deployable can even be like a small function that only does one very small thing, right? So what we have here is that we've seen a transition over the years from very large applications to more fine grained, like smaller or really small applications, right? And this also has increased the velocity. It's not only increased the number of applications that are running, but it's increased the velocity of their deployment, right? So you can have applications that are being new versions of the applications can be deployed like every few minutes, even in some cases. So when this happens, basically, and when you're trying to run this stuff on the cloud, right? So you're paying for per memory, you're paying per CPU that you're consuming. This means that your startup time and your runtime footprint of the application become your applications become very important, right? Because when you had like a big old application that you just deployed on a huge server, you didn't care. It didn't really matter that your framework was efficient. But now when you're deploying like multiple copies of the same application and you've broken down the application into separate parts, you really care about being able to fit as many processes of the instances of the application of like parts of the application into a cloud machine, right? Because the whole point is you want to deliver as fast as possible and also pay your cloud providers as little as possible. This inherently is, or I should say was problematic in Java for a while. So let's say, okay, Kubernetes was released, like first like production version was released around 2015, I think. And it immediately became a really big success, right? Because it solved a lot of problems that people had, some problems that people had. Let's say some problems that a lot of people had when deploying their applications. So it allows you basically to focus more on your application than on infrastructure issues. So you don't want to care about where the application will be deployed, or what will happen if an instance goes down. Like Kubernetes just takes care of that. And at the time, Spring Boot was released like a few months before, like the first version, I think, which meant that now people could use a framework to deploy their application very easily to Kubernetes instead of using the old style of application servers, right? But Spring Boot, for all its awesomeness, didn't really focus on the runtime footprint of the application, right? So it has some architectural issues that really get exacerbated when you deploy multiple instances of these applications. You need to deploy them really fast, right? So we'll go into more detail of what those problems are. The basic problems are that most frameworks load far too many classes. They are way too dynamic, and they perform a lot of initialization at runtime, right? So what's the result of all this, right? The fact that they load too many classes should be self-evident of what the problem is. The problem is that they consume a lot more memory. But not only, but the fact that they load too many classes not only means that they consume more memory than they should, but they also start up slower than they should, right? Because class loading does take up a small amount of time, But when you have like tens of thousands of classes being loaded, then that really means a lot of time is taken up. So the dynamic nature of these frameworks basically means that it makes it super easy for users to develop applications, like with annotations and things like that. Very, very declarative. You need to write minimal code. Um, and the framework just does a lot of things magically based on what is present in the application, like what dependencies are present or what framework, what annotations are being used. But all this dynamicity, it costs, right? It costs both in terms of startup time and in terms of memory that is used. And the final part, again, self-evident, like anybody who's developed like a library or a framework or something knows that in order to bootstrap this library framework, you need to do a lot of work, right? So you need to parse configuration files, you need to like create perhaps dynamically create classes, anything like that. You need to look up things. So all that is done at runtime with traditional frameworks. So and here, basically what I described earlier is what we see here in a diagram format, right? Or let's say a cool picture. So on the left here, we have build time, right? So this is in traditional frameworks like Spring Boot or like all the other stuff you have out there. When you package the application, you want to create a jar, right? So the jar is what's actually going to run. When you do that, you create it with Maven or Gradle, so MVN package or Gradle build. What happens at like MVN package time is basically nothing, right? It's just Maven packaging the application into a jar that can then run, right? So there's no logic going on in there. But that means that when you actually run the jar at runtime, then you need to do a whole bunch of things based on how sophisticated your framework is. So for a Spring Boot, which is like a super sophisticated framework, it has to parse a whole bunch of configuration files like properties files, YAML files, XML files, whatever. Then it needs to scan all of the classes of the application and the dependencies to figure out like where various annotations are. So because any part of the application could be annotated with various Spring annotations. So it needs to find those. This takes a lot of time. And then once it's done, like scanning all for the annotations and all the configuration files and all that, then it needs to build like its internal model, right? So Spring's internal model of how like different components are wired together. And once it's done that, then it can actually like start doing whatever it needs to do, like start threads or open connections or whatever. So if that's the problem, right? The problem is that all this work here is being done at runtime in these traditional frameworks, right? So what's the basic idea of Quarkus? Like, what does Quarkus do different? What does Quarkus do better? So the basic idea is that we try to take a whole bunch of the work that we mentioned here that is done at runtime, and we try to move it to build time, right? So remember, build time is when you invoke MVN package or Grader build to create a jar, right? We try to do work at that phase, right? So when you're building the application, we try to scan like the whole application for annotations. We scan for configuration files. And a whole bunch of other work. And the result of all this is that you can, first of all, you do a lot of work just once, which is build time, instead of like every time the application runs. The second thing is that you can get rid of a whole bunch of classes. So for example, if you just need to parse like a YAML file, there's no need to have YAML configuration, YAML classes to parse YAML files at runtime. If all you need to do is parse it at build time, you can do that at build time and get rid of all those classes, those YAML classes. So that's the idea. That the same applies for a whole bunch of other things as well, right? So that limits the number of classes you need to load at runtime. Of course, all this work limits the memory a lot and the startup time. And there's also another benefit, which we'll talk about later on a little bit, that Quarkus has to do little or no reflection and doesn't have to create any dynamic proxies. So this is sort of a technical detail, but first of all, it does affect startup time and memory consumption. And second of all, it does also have an impact on the use of GraalVM native image, which we'll talk about a little bit more. Basically, GraalVM allows you to take a Java application and turn it into a native application. So native binary, or Windows binary, or Linux binary. But in order to do that, it's very hard to do that, let me say, when there's a lot of reflection or dynamic proxies or things like that. But with Quarkus, because there's none of that stuff, making the native binary is a lot easier. So in like a diagram form, what we saw earlier with the parsing of configuration files, scanning for classes, annotations, things like that, building the meta model, all that stuff happens at build time, right? So when you're packaging the application to create a jar, a container, whatever, all that work is done at the build time. And that means that when you run the application, all that stuff is already ready, right? So all you have to do is just load the classes that contain the model and just start very quickly. So the Quarkus way, right? Contrasted to the other, the old approach where you do everything at runtime, the Quarkus way where you do everything at build time means that JVM mode starts very much faster than a traditional, let's say, framework that doesn't do this. And it also enables GraalVM native image, which again, GraalVM allows you to take a GraalVM native image, allows you to take a Java application and convert it to a native binary, right? And it's very hard to do, but because Quarkus does all this work, it makes this work for GraalVM so much easier. So you're probably wondering, okay, well, that sounds cool. But what does this look like in practice, right? What can I expect from Quarkus compared to one of these other frameworks, right? Well, when we're talking about the JVM mode, so just like taking a jar and running it, we see that Quarkus application takes roughly about half the memory, the total memory. So not only heap, but total memory of the application when it's running. Quarkus takes about half. And in certain cases, you can speed up like half or even 5 times, right? So an application that could potentially take like 5 seconds to start in these other frameworks maybe takes 1 second in Quarkus or 2 seconds. So we've definitely seen those kinds of speeds up plenty of times. Now, if you want to take it a step further and from the Quarkus jar, you want to create a native binary using GraalVM, then you can expect to see like a fifth of the total memory space being used. So you get a very small application, let's say like comparable to Go, maybe, right? To a Go binary. And it starts up in tens of milliseconds. So you can see like applications starting in 10, 20, 30 milliseconds. So which is amazing for running in serverless mode, right? So that's like the general rule of thumb. Now, I did talk about native image, and it sounds great. Like you get this smaller image, you get this, you get super fast startup time. So a lot of people are wondering, okay, like when do you use JVM mode? When do you use GraalVM native binary mode? Well, both have like different characteristics, right? So if you're looking for the highest possible performance, that is like in terms of throughput, right? So if you're looking to serve the maximum number of requests per second, then the JVM mode, like running running the application as a jar, is fastest because the JVM does dynamic compilation of code, so it can optimize the code that it runs in a profile guided way. So it can take various decisions based on the code itself, on the actual running code, and produce assembly code that is pretty optimal. So if you need the fastest performance, like if your service, let's say is in super high demand, and you definitely need to serve a very large number of requests per second. Then the JVM mode is probably the best. Right. Also, the garbage collectors in JVM mode are far more sophisticated, and you have a huge collection of them and a lot of tuning options for them. So the other very important part is that with the JVM mode, you get all the standard JVM tooling, right? So you have agents, you have all this observability space, all that cool stuff that people rely on to have their Java applications running in production, right? But now with the GraalVM, the native binary mode, well, you don't have any of this standard monitoring tool because there's no Java agents, for example, are not supported. You only have a few garbage collectors that are, but things are getting better on that front, but you're still a lot more limited than what you have on JVM. But you have extremely fast native binary startup times, right? So like I said, tens of milliseconds, maybe 10 milliseconds, 20 milliseconds. That's instantaneous, basically. And you have a much smaller application in terms of memory usage, right? So if that is very important, so let's say you have like a scenario where you have like medium load, let's say, but it's very important to be able to consume very little memory and start up extremely fast, then going to native binary using GraalVM and Quarkus might be a good option. Let's see. Basically, I said that Quarkus has been around for 3 years now, right? More than 3 years, 3.5. So there's, and if you've heard some of this like intro to Quarkus stuff before, but it's been a while since you've gotten an update on like what are the latest things that we've delivered. Well, here's a list of the like non-exhaustive list of the most important things, right? So some of these we'll see here today in the demo that I'll attempt to do in a few minutes. So dev services basically means that we use test containers to start things like relational databases for you. The result is like a development experience that is much smoother than anything else out there. It's very awesome. Then we have Hibernate Reactive, so a version of Hibernate where you can use a reactive APIs, and so everything's non-blocking, which allows you to achieve higher throughput than regular Hibernate ORM. So Rest Easy Reactive, which is our re-implementation of JAX-RS, which allows you to use both reactive and non-reactive APIs. So it's much faster than our the previous JAX-RS implementation we had, and it consumes less memory. Also, we have things like continuous testing, which I'll show here, which basically allows you to seamlessly develop your application and run tests at the same time. So we'll see that. Dev UI, that's a console for your application, your Quarkus application, that allows you to see inside the application while you're developing it. It has some pretty cool features. We'll see a few. Then you have like gRPC support, GraphQL support, function as a service framework, Kotlin coroutines. So a lot of people are very big fans of Kotlin. Quarkus provides first-class support for Kotlin, and coroutines was like one of the most requested features. With that, let's try and do a quick demo. I know I don't have much time here, so I'll try and show the basics, right? So let's see what we have. So here is my IDE, right? So basically, I'm going to show you how what developing a simple Quarkus application looks like. First of all, though, I want to show you like where you can go to create a new Quarkus application, right? So you go to code.quarkus.io. That's code. You just write code Quarkus on Google. Then you'll just first result code.quarkus.io. For those of you who are like familiar with Spring Initializer, this is basically the similar thing. You can choose what extensions you want. We have a very large list of extensions. So basically, depending on your, like, let's say I want REST, tells me that I have Rest Easy Reactive with Jackson support or Kotlin support, any of that stuff. If I want like Hibernate, I write that here. I I get hibernate, a bunch of hibernate things, and I can select these and like generate my application, right? I'm not going to do that now. It's super easy to use. I already have the application generated here, right? So this is my to-do application. What the to-do application is basically is simply like a to-do application. It sort of looks like this, right? So I've copied a UI into here, very simple UI. This is like a standard, let's say, demo type of application where you want to showcase a framework, right? So all it does is basically just allows you to track some random to-do items, right? So what are we going to do here? We have our Quarkus application. It's a Maven application, Java 17 that I've generated. And what I'm going to do here, first of all, is I'm going to start Quarkus in the dev mode, right? So Quarkus has this special mode that we call the dev mode, which we use to which users use when they want to develop their applications, right? So when I'm developing an application, I don't have any code written yet, right? So the whole idea here is that Quarkus can dynamically reload your code as you are writing it. So now, as I don't have any code and I want to implement this, right? So this screen is not showing anything. I want to start showing things. So let's say I want to write some code. I'm going to go through this pretty quickly. I'm gonna only explain the basics. So basically, I'm going to model my to-do with as a Hibernate JPA entity, right? So that's why I'm annotating it here. This panache entity thing here basically is used to provide like active record type support. So my to-do will have methods like save, delete, find, things like that, right? So my to-do here, I'm just going to add a few fields. I'm going to say title. I'm going to say Boolean completed. Oops. I'm going to say public int ordered, and I'm going to say public string URL, right? So I'm going to add, these are the fields I'm adding, right? And also, okay, just having the entity isn't enough. I need to expose it to through a REST API. So the REST API that this application looks for is under API, which is why I've added this here. So what I'm doing here is I'm adding a JAX-RS. I'm exposing the to-do entity through a JAX-RS REST API, right? So for those of you who have not used JAX-RS, it's very similar to Spring Web or Spring MVC. So like think REST controllers, things like get mapping, things like that. You have the similar annotations in JAX-RS. I think it's very easy to use, and you'll find a bunch of information both on Quarkus site and like the internet. So basically, all I'm doing here is I'm annotating a class with API, path API. I'm going to say this method is a get method, and what it does is that it lists all the to-do entities. Remember, the to-do entity here had these fields, and I'm just listing them all, right? So if I refresh, and I see here that this it did not work currently, so I got to see what's going on. Okay, right. So Quarkus so automatically what happened here is that Quarkus automatically reloaded my code, right? I didn't have to restart the application at all, right? So just remember that I started NVN Quarkus dev and I just started writing code. I was hoping that I would get it right, but I didn't. Because what I see here is that Quarkus is complaining that it tried to insert something and it didn't. What's it saying here? It's saying that column ordering does not exist, right? So, this was supposed to be ordering instead of order. And I'll explain where that came from. Now, if I refresh here, automatically everything works, right? So let's just see what I did. I took the to-do, right? I wrote code. I refreshed. I saw I made a mistake. I corrected the mistake based on the information I had, and then I refreshed again, and everything just worked magically, right? So no refresh is needed. Like everything was instantaneous. Now, you're probably wondering, okay, well, this guy just like wrote some code, and he got this data on the screen, right? Well, where did the data come from? Well, that's an excellent question. So basically, Quarkus allows you when you're using Hibernate, it allows you to insert test data in the database with this import SQL file. So when I'm using this, Quarkus automatically inserts these 4 entries into my to-do table, which is why we're seeing here: introduction to Quarkus, Hibernate with Panache, visit Quarkus site, and start Quarkus project. Right. And the first one is completed, the other ones are not, which is why this is stricken out and the other ones are. So that's amazing, right? Immediately you see that, wow, this is so productive, right? I mean, I'm just writing code and I don't need to refresh anything. I just refresh the browser and everything just is displayed automatically on the screen without me doing anything. And now you're probably wondering, okay, well, where was the database, right? Because this application is using Hibernate, and it's also using Postgres, right? But I never said where the Postgres database was, and I didn't show you that I was running any Postgres or anything like that. Well, there's some more magic here. Before we see where that came from, let's go and open the dev UI, right? And how do we open the dev UI? Well, this Quarkus terminal here, oops, excuse me, that was a mistake. Here, I want to see, this terminal allows me to do a few things. And one of the things it allows me is to open the dev UI in the browser. So I could just hit like a localhost 8080 /q/dev. And what this dev UI does, it gives me a view of the Quarkus application, an insider view of the Quarkus application. So you can see a whole bunch of things like the Hibernate entities that I'm seeing, that I have in my application, right? I can see that from here. I could even reset the database if I wanted to. But what I want to show you here is the dev services feature, because like I said, there was, I see like data pulled out from a database, but I don't see where the database came from. Well, the answer comes from a feature called dev services, and I can see this dev services here. And basically what that means is that when Quarkus sees that you're using a relational database, and it knows that by the extension you're using, right, this dependency here, and it also sees that you have not configured a relational database anywhere. So no URL for the database, no username, password, nothing like that. Then Quarkus knows that, you know what, I'm going to help you out. I am going to start a Postgres database for you using test containers. And that's exactly what it did here, right? So we see that it started this Postgres. It pulled a Docker container, Postgres 14. It started it. It mapped this port to the standard Postgres port, and then it passed different configuration properties to Quarkus, right? So this says that essentially when we started the database, we passed this information here to Quarkus. So the URL and the username and the password. And if I wanted to verify this, I could do like Docker PS and see the Postgres container here. So that's amazing, right? I didn't have to run anything on my own. This just happened automatically. Right? This is an amazing feature, and it's made possible because of the awesome test containers library. So now with that out of the way, let's very, very quickly show what continuous testing is. So basically, continuous testing is our way of allowing you to do something like TDD, right? So basically, if you want to have your application running, and you also want to at the same time run tests, then you can do this. So I'm just going to write a test here. When then status code 200. So I'm going to run the tests here. And I am going to, first of all, I'm going to create a test that shouldn't pass, right? And that's exactly what happened here, right? So I'm exercising this API here from the test. And I'm saying in my test, like I expect the status code to be 200, but that's not correct, right? The status code is 201. So I made a mistake in my test. If I fix the test and go back to the console, then all the tests are now passing. But again, I didn't run anything here, right? I'm just I didn't refresh anything. I didn't do anything. I just fixed my test and everything just worked. And if I go here and say, if I throw an exception, oops, sorry about that. If I go throw new runtime exception here, then my test won't pass, right? Because now it gets 500 instead of 200. And if I wanted to change that and expect 500, then magically everything just works, right? So my point here is that with continuous testing and the dev mode, you can write your code, your application code. You can write your test code and never ever have to refresh anything, right? Quarkus takes care of that automatically. So that's it with my demo. Let's head back to the slides and get to those really, really quickly. So I'll go through this really, really quickly and say, okay, let's recap. Like, why Quarkus, right? The first benefit. I haven't shown any numbers here, but you can see these on the Quarkus website, and I also encourage you to run these on your own to see that Quarkus performs extremely well, both in terms of memory footprint and startup time, whether you're using JVM mode or you're using GraalVM native image mode. Second, we saw this in action, though, developer joy, right? We call this developer joy. The fact that I have to do almost zero configuration, the fact that code refreshing just works automatically, tests just run automatically, all that like just brings me joy. I don't have to run any containers, I don't have to do anything. Things just work, right? Third benefit that we didn't show here, but it's very important for Quarkus is that you can use both reactive and non-reactive APIs in the same application, right? We have first-class support for both. Fourth is that we integrate with all the major libraries and the frameworks out there. So anything you're used to and you use as a productive Java developer, you can just pick it up. There's an extension in Quarkus for you. And the fifth benefit is that we've been here for 3 years, but we continue to innovate all the time. Like, we have so much new stuff and so much more stuff coming in the pipeline with like Quarkus 3. So there's continuous innovation. We never rest on our laurels, and we continue to improve as much as we can. So that's it. That's about as fast as I could go for this talk. I hope that I've spiked your interest in Quarkus. So I'm hoping you'll check it out some more. So here's some useful information for you to check out: our website, our chat, videos on YouTube for various things, Twitter, and of course you can star us on GitHub. So with that, I'm going to stop sharing, and perhaps like if we have any questions, I think we have a minute or so to go ahead and answer them. So yeah, now's your chance. Otherwise, we can wrap it up, and I really hope that you'll be able to take this, like the stuff you saw here, and run Quarkus on your own and actually compare it to what you're using in practice. And any questions you have, you can address them to me or on our Quarkus community. So yeah, we don't seem to have any questions right now. So I guess I'll thank everybody for being here. I thank you to the hosts who were kind enough to host this presentation, and I'll see you folks around. Thank you very much.